Okay, so in this video we are going to do an example problem from trigonometry and using right triangles, and we may or may not squeeze. We'll probably just do one triangle per example. So I've got some metric graph paper on here that I'm sure this is not going to really look all that awesome on the video, but we'll do the best that we can. Okay, so one of these boxes, let me just go up here. One of these boxes on this graph paper is 1 centimeter by 1 centimeter. So what I'm going to do is I'm going to make a triangle. 1, 2, 3, let's just go over here and count it out. I'm going to go here. And then I'm going to go, let's say like here. And then I'm going to complete the triangle down here. Okay. So, if I look, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's 13 centimeters, and that's 4 centimeters. And so what I want to know, and that's my right angle right there. And so what I want to know is I want to know what's this angle, I want to know what's this angle, and I want to know this distance, which we're going to call C. Okay, well, let's just jump right into it. Let's start off with our good old friend Pythagorean theorem. So we have a squared plus b squared equals c squared. So let's call this a, let's call this b. So we're going to say that this is 4 centimeters squared plus 13 centimeters squared equals c squared. So I can say c equals the square root of 4 squared plus 13 squared. And I'm going to get out my calculator, and I'm going to do this all on one line. And so you can see I go second, I get the square root button, and I do 4 squared plus 13 squared, and I close the parentheses, and I get 13.6. So I get C equal 13.6 centimeters. Now let's just check that. Let's see if we can figure this out so you can see it on the video right here. Let's take that off of it. This will probably work a little bit better. Okay. On it right there, so you can see right there is 13 centimeters, hopefully, maybe. You can see right there is 4 centimeters, and if I go like this, I am at about 13.6 centimeters. So C is 13.6 centimeters. Okay. Now, to find this angle right here, well, I don't really want to use the 13.6. And the reason why I don't want to use the 13.6 is because suppose that I got that wrong, or suppose that there's rounding error or something along those lines. I'm not 100% sure that that's a good number or that it's a very accurate number. So the numbers that I want to use to find this angle are 4 centimeters and 13 centimeters. Well, 4 centimeters, that's my opposite. And 13 centimeters, that's my adjacent. And I think back on what I remember from the previous lecture, and I remember, oh, opposite over adjacent is equal to tangent theta. Okay. So I have 4 centimeters over 13 centimeters is equal to tangent theta. Well, how do I do that on my calculator? If I know the angle, if I want to say I've got a 45-degree angle, if I do the tangent of 45, it says, oh, the tangent of 45 is 1. But suppose I want to go back the other way. Well, right above tangent is tangent inverse. And so I do second tangent, and that will get me back the other way. So what I really want to do is I want to say that tan inverse of 4 over 13 is going to equal theta. So I do this on my calculator, and I'm going to do second tan 4 divided by 13, and that's going to give me 17.1 degrees. I'm just going to call it 17 degrees. Okay, so then I take my colorific protractor right here, which has seen some better days, and I go, there's 10 degrees, hang on, gotta get it lined up. I put the vertex of the angle right there. I put one of the sides at 0 degrees, and right there it goes 10, there's my 15, there's 16, there's 17, so I'm measuring that is 17 degrees. Okay, and so I've got that. Last thing is, how do I get that? It's not so hard, because I know that the angles of a triangle, all the angles of a triangle add up to 180 degrees. And so since that's 90 degrees, I know that these two are complementary angles, and so they add up to 90 degrees. So 17 degrees plus phi is equal to 90 degrees. So phi is equal to 90 minus 17, which is going to be 73 degrees. So I know that's going to be 73 degrees. Okay, and so there I have used trigonometry to solve that triangle.